Okay, I think I've got the recording going. What I'm going to do is go over to the paper and talk about chapter 10. So what's happened today, it's a result of the storm. I had trouble getting into Zoom this morning. So what I'm going to do is make a video and we'll can discuss it further on Wednesday. So chapter 10 is about positive and negative numbers. And so what you really need to understand or learn to do is how to add, subtract, multiply, and divide positive and negative numbers. So there's a couple of sections at the very, very beginning, and it has to do with this. Now notice there's two vertical lines around a number. And this means get the absolute value of 3. Okay? Now the absolute value of 3 is how far is it from 0? And it's definitely 3 units. So the absolute value of 3 is 3. Now let's look at the number line and see what else we can see. So you start with 0 and you go to 1, 2, 3, and so on. Notice there's an arrow saying that this could go as high as you like. And so what happens when you go over here? And so what happens starting at 0, if you go down from that, you go into your negative numbers. And again, I just went a few numbers and then there's an arrow indicating I can go as low as I absolutely need to. So this is arbitrary. The positive numbers are going to the right, the negative numbers are going to the left. 0 is not positive or negative. And so it's just right on the fence, sitting right there. So it's neither positive or negative. So now the question is, what's the absolute value of -2? So that's saying, how far is this from 0? And the answer is 2. So if you have to do any of these problems, all you have to do is ignore the sign and just give the number. So for instance, the absolute value of 1/2 is just 1/2. The absolute value of -5 would be 5. Now, the only reason they bother with absolute value is because they explain adding and subtracting positive and negative numbers using the concept of absolute value. So it's really not a big deal. It's just ignore the sign and take the number. So the next concept has to do with these two symbols. Now back to the number line. Here's 0, here's 1 and 2 and so on. Okay. If you're going to the right, you're getting larger and larger. Now, this was arbitrary, but it's kind of based on, in this country, how we read from left to right. And so this is progress by that notion. And so this one here is greater than. Okay. This other one is pointing downward, and this is less than. So students, depending on what age they are, were taught all kinds of crazy ways to do it. One way is the small part, will be next to the small number, the large part will be next to the larger number. So for instance, this is what I'm saying. 3 is less than 5. So the small part of this symbol, this inequality symbol, is next to the smaller number. And the open part, the large part, is next to the bigger number. And so that's how they taught it to grade school students. But we need to recognize these symbols on sight. And so this is what I want you to see. If I turn this paper, this is the less than symbol. If I turn it ever so slightly, it's a letter L for less than. And so I hope that will do it. That means the other one has to be greater than. And so you recognize it by this. So for instance, one of the exercises they have you do in this very first section is if you had two numbers, a -3 and a -1, could you decide the correct inequality symbol? And so this one, remember, was less than. So -3 is less than -1 because it's further down the number line. In other words, here's the number line, here's -1, here's -2, here's -3. This one's smaller. And so a -3 is smaller than a -1, although they're both negative. It's definitely less than. And so that's the correct symbol you have to put in there. Is this smaller? So you say less than. So another one might be this, -3, and then the absolute value of 6, and you're supposed to put one of those two symbols in. Well, first of all, -3 is all set, but the absolute value of 6, you want to rewrite it into its simplest form, which is 6. So what's the correct symbol? Is -3 less than, or is -3 greater than 6? Well, this one still is less than. So this is the smaller one. This would be further to the left on your number line. And so therefore, this is the correct symbol. So let's just do one more. 14, -5. Well, clearly this number is larger because it's positive and it's a larger number. This one is below 0. And so the correct symbol would be this one. And you would read it, 14 is greater than -5. Okay. So that's our first one. Now, they ask a couple of interesting questions, and one of them looks like this. This sign here can be used to mean 3 different things. And so you might say negative, you might say minus, but in the end, there are 3 different ways this can be used. One way is like this. This is -2. In other words, 2 units down from 0. Another way this is used is when you subtract. You would subtract 2, and so it looks pretty much the same thing, so you're subtracting 2. Another way this is used is to mean the opposite. So for instance, if there's a negative or sign like this in front of a number, you can interpret it as the opposite of something. So whatever this number is. So for instance, if it was the opposite of 5, you would have to say, this one's assumed to be positive. There's no sign there at the moment. And so +5, the opposite of +5 would be -5. The opposite of -5. Now, opposite, -5, the other side would be +5. So when you do opposites, basically, if it's positive to begin with, it goes negative. If it's negative to begin with, it goes positive. So this gets us back to this problem here. The opposite of -2 would be 2, or +2, but we don't really say it positive. So hopefully that is starting to make sense. I'm going to do this one. The absolute value marks are vertical. And so what you have to do is deal with order of operation. So for instance, you would do this part first. The absolute value of -2 would be 2. So this much here would be 2. But then there's a negative in front of it. So the opposite of this would be -2. So they make a fuss about this at the very, very beginning, but it actually turns out it's not all that big of a deal. And so I think that first section, 10.1, which is due tomorrow, should be fairly simple. Can you do absolute value? And the answer is 4. Can you do the opposite of a number? The opposite of -3 would be 3, that kind of thing. And so it's not a big deal. It's a whole section, but I think once you get familiar with this, and maybe you've seen it before and maybe not, then you know the absolute value of 6 is just 6. And so they would write it like that. So the very first thing when we actually start adding, the first thing we're going to do, this is 10.2. When we add, I'm going to start with this, 5 plus 2. Well, this is what you know already. And so this one is taken as a +5. This is taken as a +2, and we're adding. And so you know what to do. 5 and 2 make 7, and it's positive. Now, what would happen if you added 2 negatives? This is -3. And so here you are, this is 0, 1, 2. This is -3 where you're starting with, and then you're going to add a -4 to it. So what you're going to do is go even lower on the number line, and you're going to end up at -7. Now, how are you going to do this without drawing a number line and counting over 1, 2, 3, 4? How are you going to do it? Well, the simple rule is this. If you're adding, which we are, and both of them are negative, you take the absolute value of each. The 3 and the 4 make 7, but these are both negative. Now, many times students have good luck thinking about something other than just this positive negative number business. And so let's talk about checkbooks. Money seems to work. If you had $5 and you added 2 more, you would get $7, and it's clearly on the plus side. But if you owed $3, so it's 3 to the minus, and you owe another $4, now you owe even further. You owe $7, and so it's minus. Now, you probably have heard me before talking about, I originally taught in Maine, where the temperatures in the winter are very, very cold. And so this is what I call a very bad day. It started out 3 below 0. So here's 0, and I made my number line vertical, so it's like a thermometer. So it's 3 below. And then what happened? Oh my, instead of the temperature going up, the temperature went down. And so now Now you're at -7. Now this works for students there because they understand it. Sometimes the temperature starts out not so, this is not great, believe me, but then it gets worse. And so then you end up with a -7. So let's try a different problem. 8 plus -3. Now, the reason I put it in parentheses is because I had a plus sign and a minus sign, and I didn't want to get everything tangled up. I wanted you to see clearly that it's an addition problem. So I have +8, this is assumed positive, and now what I'm going to do is take the opposite of 3, so I'm going to go down 3. It's really, I need to subtract the two absolute values. So the 8 and take away 3 is 5. Now this makes sense, and I made a big deal about it, but that makes sense. You had 8 to the positive, and then you added only 3 negative. And so clearly you're still on the positive side. So in money, you had $8 and you spent 3. Now you have $5. Now, let's say you started out negative, okay? And then you added 9. So if you were 6 below 0, and then you added 9, you're clearly above 0 because you have more positive than you have negative. And so how do you do it? Whether you don't think of money or don't think of anything particular, you take the two are opposite signs. One is negative, one is positive. So what you do is you subtract the absolute values. 9 take away 6 is 3. And what you have to decide now is it a +3 or a -3? How do you tell? Well, the 9 is the bigger number, and so you have 9 to the plus, only 6 to the minus, and so it's definitely +3. On the other hand, if you had -10 plus 7, you have the negative going and you have the positive going, and it's addition. You subtract the two absolute values. So you would kind of ignore the minus and just say 10 take away 7 is 3. But is it a +3 or is it a -3? Well, it's clearly negative because in a sense, the negative wins in this case. There was more negative than there was positive, and so it ends up being -3. So let's go over this and see the big picture. If it's addition and you're adding the same signs, okay? So they're either both positive or both negative. So I'll give you some examples so that you know. If we had 7 plus 4, and this was positive, so this is positive, adding another positive. All you do is add the two, the 7 and the 4 absolute values, and it's positive. If they were both negative, but they're both negative, so this is what I call the very bad day. You add the two numbers, 5 and 9 makes 14, but then you copy the sign. So this is like borrowing and borrowing some more, and now you're in debt $14. Okay? So if that's the case, if you have the same sign, you're adding the absolute values and taking the sign of the two. So in this case, the two were positive. In this case, the two were negative. But if they're opposite signs, okay, an example, 12 plus negative 14. What you're adding, but one is positive and one is negative. What you do is you subtract the absolute values. So in this case, you take 14, take away 12 is 2. So you subtract with the bigger number first and the smaller number second. And so this answer is 2. But then the sign that you select is for the larger number, the larger absolute value. So let's see, I had a positive 12, I had a negative 14. So there's more negative than there's positive. It ends up being the winner is negative. And so a second example, just to do with opposite signs, if I had negative 7 plus positive 12. I'm adding. The two numbers are opposite signs. One is negative, one is positive. So what you do is you subtract the absolute values. And the 7 and the 12, you would basically say, subtract in the normal way with the bigger number on top and the smaller number here. And so your answer is 5. Then you have to decide whether it's a positive 5 or a negative 5. Notice how the 12 is positive and it's a bigger number, so the answer stays positive. So if you've done this before, this is sort of like you can do it without even thinking. If you've never done this before, then it's a slightly different problem. And so that's what we need to make sure we're able to do, okay? So this is addition. And it does make sense. You look at the numbers, decide whether they're both the same sign, then you're really just adding. And you pick this, you copy the sign, either positive or negative. When it's positive, you don't say plus, you just say the number and it's assumed positive. But when they're opposite, you subtract the two numbers because they're working against each other and take the sign of the larger number, so the larger absolute value. So there are other ways to explain this, but that's how I'm going to explain it this first time. And so let's see, let's give a couple of examples. This is still 10.2. Okay, so these are some problems I found. So this is going to mix up absolute value and negative. So in this particular problem, the absolute value needs to be done first. And so the absolute value of a negative number is saying, what is it? And the answer is 9. And so you would write it like this. You wouldn't say plus 9, you would just say 9. Now that's added to negative 7. So this becomes the problem. We kind of ignore this. This was sort of a mess and sort of do this. This is addition. The signs are opposite. What you end up doing is taking the absolute values, the 9 and the 7, you subtract them, and you get 2. Now you slow down and say, is it positive 2 or is it negative 2? And because the positive number 9 was bigger, it's positive. And so that's how that problem ended up. I want to do this next one. sometimes they're going to give decimals. And you already know how to deal with decimals. And so the question is, how do you adapt it? Positive and negative numbers. Notice this is an addition problem. It's a negative 1.3 added to a negative 2.5. This is the case where both of the signs are the same. So we end up adding 1.3 and 2.5. And so when you add them, that's an 8 and that's a 3. So I'm getting 3.8. But remember, these are both negative. So this sign, it keeps it negative. Notice that this was addition. I added the two because the signs were the same. Let's try another one. This is also a decimal, 24.8 and minus 10.4. This is addition. The first number is positive because you see no sign. The second number is negative. The signs are opposite. So what you end up doing is subtracting the two numbers. And I'll put the bigger number on top, 24.8 minus 10.4. 8 take away 4 is 4. This is 4. This is 14.4. I've got the right number. Now I have to decide what is the correct sign. And so this is positive. This is the bigger one. So this stays positive. And if you look at it a little bit, you think, oh yeah, that makes perfect sense. Maybe it does, maybe it doesn't. The next one is a fraction problem. And this is the way they wrote it. Negative 5, 6, and then plus parentheses, negative 1, 6. Now, don't let the fractions throw you because this is actually an easy one to do. But they tend to write the minus sign, the subtract, the negative, kind of level with the fraction line. But sometimes it's almost hard to see the negative. And so what I suggest you do, and this is what I always do, instead of putting it out front like that, I put it in the numerator. And then I'm more likely to see it. So this is negative 1, 6. I would put negative 1 over 6. This, to me, makes it easier to see. And now I'm going to actually do the problem. So this is, I'm going to, fortunately, like that. There's an advantage to having it here and not here, because when it's out front here, you're saying, does the negative go with the 5? Does it go with the 6? Or does it go with both? And you make a mistake. This way, you're putting it here. This is a good way to have it. And so I think it's easier to see. So this is addition. The denominators match. So our common denominator is 6. So what I have to do next is add these two numbers. So I need to add a negative 5 and a negative 1. I'm using parentheses, so it's really clear what I'm adding. A negative 5 plus a negative 1. They're both the same sign. They're both negative. And so 5 and 1 is 6, and they're both negative 6. Okay, so I'm going to put my negative 6 here. Now, 6 divided by 6 is 1. And the negative goes in the front. So this is negative 6 divided by 6, negative 6. 6 over 6 is 1 with the 1 negative. And so that particular answer ends up being negative 1. Now, if you've had it before, it's a piece of cake. If you haven't, my goodness, then you're wondering how you're going to survive this. I want to do one like this with 3 numbers. The first number is negative. The second number is positive. The third one is positive. What I tend to do is put my positive together and my negatives together. I think that might be the easiest. I'm going to put these 2 positives together. It's almost like a checkbook. This is working in the positive. This is working against us. And so I'm going to put these 2 together. 2.54, 2 and 54 hundredths plus 0.4. And I could put a 0 here. This is why we did decimals. So I'm going to add these now. This is 4, this is 9, and this is 2.9. These are both positive, so this stays positive. Right? Then this is negative 3.8 plus how this turned out, 2.94. Okay? Do not panic. You're adding. One's negative, one's positive. Which means you end up subtracting the absolute values so that you find the difference. And you put the larger number on top, 3.8. And you put the smaller number, 2.94, on the bottom. You end up subtracting. I'm going to add a 0 here to make it easier. It's like money. This would be a 6. We would borrow. This would be an 8. So when you subtract 3.8, 3 and 8/10, and 2.94, putting the larger number on top, even though it was negative, so that you can subtract properly, the answer came out 0.86. But the question becomes, is it a positive or is it a negative? This is bigger. This is -3. This is +2. So it ends up being a negative answer. Okay? So if you're losing 3 but only gaining 2, even though there's more to it, you end up negative. If you relate it to money, you had $2.94, but you spent this much. You're now on the negative side. You spent more than you had. How is that? Let's do a couple of examples just to be sure we're clear. 8 plus -12. This is clearly addition. Notice the use of parentheses is not meant to be multiply. It's meant to so that you can clearly see what you're doing. I'm going to take the parentheses away and you'll see the problem without the parentheses. The sign plus and then the sign minus, and it's like you're not really sure whether you're adding or subtracting or what. And so when you put it in parentheses, it's a visual thing. It's not a math thing. It's like you want to see, I had a +8 to it. I added a -12. Because the signs are opposite, we end up subtracting the 2 absolute values and getting 4. 12 take away 8 is 4, but what kind of 4? The negative is the winner here because it's the larger of the 2, and so the answer becomes -4. Let's try this one. -12 and -20. It's clearly addition. I marked it off so that we could tell this is negative and this is negative. They're both the same. And so you borrowed and you borrowed some more. So what you end up doing is adding the 2 absolute values 12 and 20 make 32. But now what's the correct sign? You borrowed and you borrowed. Now you're further in the hole, so to speak. It's negative 32. Now, when we get to multiplication, two negatives will be different. And so the first thing you do is stare at the problem long enough to see exactly what you're doing. In this case, we're adding. And so we need to use the rules for addition so that we get it right. Negative 15 plus 3. This is clearly addition. Starting with a negative 15, adding to it a positive 3. The signs are opposite, one positive, one negative. So you end up subtracting the 2 to see where you end up. And so we end up with a 12. But the real question is it a positive 12 or is it a negative 12? It's almost like a tug of war. The negatives have 15, the positives have only 3. The negatives win in this particular case. Does that make sense? With any luck? Okay. The interesting one, and I hope adding makes sense because there's only, 2 versions of it. Subtraction, this is 10.3. Subtraction, one way to explain it is to convert it to addition. And so we're going to change it to addition. We're going to add the opposite of the second number. This is one set of rules that will help us do subtraction. Now, let's see what we're going to do. I'm going to take 8 and I'm going to subtract 5. I'm going to put the parentheses around it so it's really clear. I'm subtracting a positive 8, subtract a positive 5. Now, you know the answer to this, but I want to show you how this rule is helping us. We're going to convert it to addition, which means we're going to take 8 and copy it exactly. We're going to change the subtract sign to add. And we're going to change the second number to its opposite. So the opposite of 5 would be negative 5. Well, we made a big fuss about all this, but what's the final answer? 8 and negative 5. See, we have the rules for addition. The 2, we have opposite signs. We subtract the 2, and the larger one is positive, so it ends up being positive. In many ways, this is what you've been doing all along when you first learned subtraction. If you were in grade school, and I mean, like 8 years old or 6 years old or whatever, and they were teaching you to subtract. And so you had a whole page, 9, and so on. So you had a whole page of subtraction. And so maybe they handed you out a whole page and said, oh, by the way, we've been adding, but now this is our first day, we're going to subtract. Now, remember, you're a little kid. You haven't ever seen this before. And so you don't want to add by mistake, do you? And so what do you do to remind yourself that it's not addition anymore? This first day is subtraction. This is what you do. you change the +4 to -4. When you wanted to subtract this, we changed the +6 to a -6. And in this one, we've changed the +5 to a -5. This is what we've been doing all along. And so this is the way you saw it. But that's what really we've been doing. And so it wasn't clear that's what we were doing. We thought we were just subtracting, but that's what we're doing. We're changing that second number to its opposite sign. Well, if that's the rule, let's try a few. So if I have 9 subtract -3, I use the parentheses for as a visual aid so that it was very clear. It's a +9, it's a subtract, and it's a -3. Once once it's clear it's subtract, I can then change it to an addition problem by copying the first number, changing it to add, and change the second number to its opposite sign. So the opposite of -3 is 3. Once you've done that, try to ignore the original problem and just see it from here. We've completely converted it correctly to an addition problem. 9 + 3 is 12. So it may not have registered before, but once you converted it, things looked better. And I have another way, but let's wait a minute. -5 subtract -6. Once it's clear, it's subtract. There's just one rule. The first number is copied. I can put it in parentheses if I want to. The subtract sign is switched to addition, but when I make subtract into addition, I change this to its opposite. The opposite of the opposite of -6 is 6. Now it's easier, and I'm going to move this like that so that all you can see is this. A -5 plus a 6 is the same as 6 plus -5. You're subtracting the 2. 6 minus 5 is 1. The question is it +1 or -1? It's definitely positive because the 6 is bigger and it's a positive number. This is smaller, so it's positive. It's really 6 minus 5. Okay. Now, if you've seen this before, you start to see a pattern that the subtracting a negative always ends up positive because it's adding, and then this goes to its opposite, and so it always goes to a plus sign. So occasionally people were taught that minus a minus or subtract a negative becomes plus. So when you see this back to back like this, a bit of a shortcut is to say 9 plus 3 would be 12. And I think after a while, you're looking for shortcuts. So in this case, I see this pattern again. Subtracting a negative is plus. So it's -5 plus 6, which again ended up being +1. Okay. Let's try this one. We just have a lot of negatives. -7 subtract -9. Negatives galore. If you take this, you know it's going to be plus. So this is one way, -7 plus +9. So this is the same as 9 subtract 7. or the signs are opposite. And so you take 9, take away 7 is 2. It ends up being positive 2 because the positive one is the bigger one. Or you recognize that this is another approach. Both will get you there perfectly. You see this as a subtract problem. You copy the first number. The subtract sign goes to addition. And this one goes to its opposite. And there you are in the same place. So it's whatever seems to work. But subtract really ends up being addition. Now, there's a few examples that they're written, it's not as obvious. But we could make a fuss about this if we want to and change it in plus and minus and all like that. But here's the bottom line. We have -3, and then we're going to take 5 more away from it. So I'm going to do temperature again. Here's -3. That's where we start. And now what's going to happen? This is not going in the right direction. This is going either further down. This is going to be more negative, isn't it? So -3 and -5. If you think of money, you borrowed 3, now we borrowed 5. We're actually, it's -8 is where we end up. Because both of the signs are negative. And so it's 2 negatives, making a bigger negative. -3 and -5. And I think just look at it and think of it as money. And it's like, wait a minute, I just borrowed $8. It's as simple as that. Let's try this one. 5 subtract -2. This is clearly a subtract problem. But the 2 subtracting a negative, I think in the end, it's going to be adding the opposite, which is +2. So it's going to be 5 plus 2, answer 7. So we're switching our subtracts to add, unless it's just like this, and you say, wait a minute, I know what's going on. Let's try this one. -4 subtract -7. Here it is again. Grab it. This gets changed. The first number doesn't get changed. This goes to plus, and this is 7. So this is the real problem. So ignore everything else and just focus there. It's an addition now. The signs are opposite. And so there's 7 to the plus, but there's 4 to the minus, or to the negative. And so what you end up doing is subtracting the 2 absolute values and taking the sign of the larger absolute value. So the bigger number is plus, so it stays positive. Okay. Now, here's another example of something where it's not written in the normal form. But I think if you just back off this problem and say, I had 15, but now I'm going to take 18 away. When you only had 15 to begin with, and this is money, and now you're going to subtract 18, you're below 0. That's all there is to it. How far below 0? Not too far, but far enough. 18 and 15. You want to subtract the absolute values. 18 minus 15 is 3, but guess what kind of 3 it is? There's more negative, then there's positive. You end up negative. Does that seem right? So without making a lot of plus minus business, I had $15, I spent 18. I'm on the negative side, that's all there is to it. Here's another one that's similar. Now, if this doesn't suit you, how I'm explaining it, then we can do it in a more complicated manner. But if somebody said, okay, you've got a debit charge of $30, now you have a debit charge of $20. Where are you? Well, they're both the same, they're both negatives, and so you add them, and 30 and 20 make 50, but it's 50 to the minus. So as the numbers get larger, you definitely have to remember the rules. So let's do a larger problem. So let's say 120 subtract 135. Now, you had 120, but the subtracting 135 means you're going below zero. So the question becomes, how far below zero? You take the two numbers the way they sit, absolute value, put the larger number on top, and when you subtract, I'm getting 15. 135 take away 120 is 15. So the number part of the answer is 15, but is it positive 15? Unfortunately not, because the subtracting part is bigger than the adding part. This was plus, this was minus, and so it's definitely minus. Now, if that doesn't suit you, you can do it along this line. The first number is copied, 120. The subtract is changed to addition. And this second number is a positive number. The opposite is negative. Whether that's necessary or not is hard to tell. I can't tell without talking to you individually. But this is how it ends up. You have 120 to the positive, you have 135 to the negative. But I could kind of see that from up here. And so it ends up being negative 15, no matter how you slice it. Okay. So this is not due till later in the week, this subtracting part. But we want you to get started with this. One of the reasons that we hopped over to chapter 10 is in order to do algebra, you're going to be dealing with positive and negative numbers. And you've got to get to the point where you're no longer making any more mistakes about the positive and negative numbers. And so we're doing it sort of early in this course so that you have more time to get this straightened out. So maybe you won't have it straightened out at the very beginning. Depends on if you've had it before. But by the time the course is over, you should have this straight enough that you're not making mistakes. So people could get the right number, but the wrong sign. Well, guess what? They're just going to mark you wrong. You know, that's the way they do. And so we've got to get both of these things straightened out. Now, I'm going to continue with the last two topics. And the last two topics involve multiply and divide. The good news it's the easiest thing to, it's easier than adding and subtracting, and that's the truth. The second thing that's so good is the rules are identical for multiply and divide. So I want to do some multiply problems. I have a 5 multiplied by a positive 3. So a positive times a positive is a positive, and that's the way it's always been. But if you have one positive and one negative, you end up negative. And it doesn't matter if the first one's positive or the second one's negative, or, you know, if there's one negative here, let me just switch the order here. It's still negative. And to complete this series, if you have a negative times a negative times a negative is a positive. So let's see what we have here. When they were both positive, it was positive. 5 times 3 is 15. That you already know. We're dealing with the sign here. When they were both negative, a negative times a negative. Remember that minus minus business that we had a little while ago? 2 negatives make it positive. But when we have one positive and one negative in any order, it ends up being negative. Now, this is true whether it's multiply or divide. So for divide problems, if you have 10 divided by 2, a positive divided by a positive is a positive, and it always has been. If you have a positive divided by a negative, that's one negative, that makes it negative 5. And it doesn't matter if the first one is the negative or the second one. In division, one negative means your answer ends up being negative. You know where this is going. If I had negative 10 divided by negative 2, all of these, we want the simplest version of the answer. And so the simplest version, 2 negatives in division, make it positive. That's the story of positive and negatives. So sometimes, well, there's a few more that are slightly more interesting. So when they were both positive numbers, you had to multiply 4/10 by 8/10. And so 0.4 times 0.8. And so 8 times 4 is 32. And then you count the decimals. Remember 1, 2. So the answer is 0.32. I put the front 0. Your job is to, this is what we already went over. This is what you already know. Your job, it's clearly multiply because there's no sign between them. So you take it as multiply. Your job is to decide whether it's a positive 32 hundredths or negative. 2 negatives, if you recall, multiplied, if I can find my page, 2 negatives when multiplied ends up being positive. So this answer stays positive. So the biggest challenge here is for you to figure out the sign. Doing the multiplications is something we've already covered. And so let me try this one. Negative 5 multiplied by 3.4, 3 and 4/10. It's a different problem. So again, it's multiply because there's nothing between the two. The parentheses are indicating that. And so what I would do is do the number part first. 5 times 4 is 20. Or get 2. 5 times 3 is 15 and 2 is 17. There's one decimal in here. So the answer is 17.0, and we might as well just say 17 because that's the simplest version. Now, this is where you have to bring in your newfound skills. When you have one negative and one positive, or vice versa, it doesn't matter the order, the answer ended up negative. So we multiplied the two, we got a number answer. Now we say what kind of sign it is, and it's definitely negative. Okay. Here's a problem, and where the rules are mixed up. And so this was going to require some multiplying and some adding and so on to get this done. Order of operation kicks in, and we do the parentheses first. So this part, we have to just say this part, -6 plus 2. So the signs are opposite. And so you subtract the 2, and you get 4. 6 take away 2 is 4, but it's definitely -4 because notice the 6 is the winner here, it's bigger. So we owed $6 and we paid 2 back, and so now we owe $4 if you're into money. The 5 is here, and then it's plus -4. So we did this first. Multiplication is second. There you are. It's a positive times a negative. You recall, here, if I can find my page. Nope, not that page. Page. When it's a positive times a negative, it's a negative. So 5 times 4 is 20. Positive times negative is negative. So what I ended up with is -4 plus -20. Notice the signs are back to back, the plus, the minus. If this helps you to clearly visualize what you're doing, then use the parentheses. They're your friend here. So we're adding. It's a negative and another negative, so it's more negative. We're in a spending spree. -4 and then -20 make -24. So we're adding the 4 and 20 to get 24, but it's negative. It's clearly, we're just continuing to spend. How's that? This is multiplication and division together, which is fine because the rules are identical. So when you have a fraction line, you try to simplify it down to a single number. And this is already simplified, at least the denominator is. So I'm just going to copy it. But this one here, 4 times -7, it's multiplied. And 4 times 7 is 28, and 1 minus 1 negative makes it negative. This is not the simplest version. We want the simplest version, just like when we had fractions, we wanted the simplest thing, not some crazy answer, but the simplest version of the answer. And so negative divided by a negative is a positive. 28 divided by 28 is 1. So we're talking +1 here. We don't say +1, although we know that's what it means. We're on the positive side in this particular case. Okay. And I know this is a lot. It depends on the student. And so I'm hoping you've seen this before, but if not, We'll work with it until you get it. I wanted you to see two problems that people make mistakes on all of the time. And I've seen it in this course and the next course and the next after that and the next after that. So we want to get it straightened out now. Notice the use of the parentheses around the -6. And this is being squared. So this means it's -6 multiplied by -6. This is two negatives. So a negative times a negative is a positive, and 6 times 6 is 36. So that answer is 36. Now, you'll see, the minute I show you this other problem, you'll see where there might be confusion. Now, this particular problem does not have parentheses. So the question is, what's being squared? Is it 6? Is it -6 like the top problem? The answer is the only thing that's being squared is the 6. And so this is 6 multiplied by 6. So you do your exponent first. Then you take the opposite. So when you multiply 6 by 6 is 36. And the minus there says take the opposite of that. That answer is -36. You can see very well why students have trouble with this and mix this up. When you have the parentheses in the original problem, it's very clear that it's -6, -6, positive 36. But this one is different. The square only applies to the number it's sitting on, which is 6, like that. And so 6 squared is 6 times 6, then the minus goes in front of it. It's almost as if it's 6 times 6 with a -1 multiplied to it. So when you multiply these two and get 36, and then a -1 times it would be -36. I've seen calculus students that made this mistake. It's just so easy. But we will keep working at it until we get it. We need to get our positive and negative signs perfectly so that everything goes well. So let me, what I wanted to do is, I'm not convinced everybody is aware of the videos that are available. So let's go back to XYZ and let's go there. And when you start looking at these homework, and notice I wanted you to see that I put 10.1 and 10.2, which probably is doable. I put it due Tuesday night, use a late pass if you need to. The rest of these are due Wednesday night. I may move that too, but that's where it is. But when you scroll down, there are videos for each one of these chapters. There's the ebook, which basically lets you read through chapter 10, and there's videos. And so I'm going to click on this. So I wanted to show you exactly where it is. These are some problems. Let me go back. And go back to the top. Let's see if I can locate it for you. So here's the calendar. Here's this. There's definitely help with the ebook. And remember, there are some places where there's actually little videos and it's not coming up. This is, and so you may read this and see if that is of use. About the opposite. You should attempt to read it. And there's definitely problems to try. It's not kind of what I was looking for, but there you are. Okay. So I'm coming back here. I'm going to stop the recording. So what I want you to do is see if you can do this homework, see if this makes sense. And if not, we'll deal with it on Wednesday. So let me stop.